Okay, so let's see what is there in this question. Some energy levels for a hydrogen atom are shown. What is the ratio of wavelength emitted in the transition X divided by the wavelength emitted in the transition Y? Okay, so the transition X, the electron is going from 2 to 1, and for Y, it is going from 3 to 1. So we want to find the wavelength. So how can we relate this thing? Obviously, we have to find first of all the energy gap between the two shells. And when the electron is making this transition, the energy is getting emitted from that. And from there, we can equate this energy with hc by lambda, and we will find the value of the wavelength and we can find the ratio. There is no shortcut for that. This is the only thing that we have to do. But let me tell you one more thing now, like the things that you have to note now. First of all, you must be remembering that the formula for the total energy of the electron in any shell is given by negative 13.6 z square by n square ev. So z is the atomic number, which is 1 for the hydrogen, so you can clearly get rid of this. So, and be very careful that the unit is electron volt, it is not joule. Now, so this will be the total energy level and total energy, and accordingly we can find the energy for 1, 2 and 3. But because this is the case of hydrogen atom, you can even remember those. For example, I'm remembering all the energy levels. You see, this energy will come out to be negative 13.6, this is coming out to be negative 3.4, and it will be negative 1.151 ev. So this is how the energies are distributed. Well, n is equal to 4, it is negative 0.84, by the way. So I remember these four values, but anyways, we are concerned only with 1, 2, 3. So now let us go for the transition for Y. So transition for Y is going from 3 to 1. So what is the energy gap between 3 to 1? So it will be this minus this, and we are interested only in the magnitude, by the way. So one will be taken positive, another will be negative. So we can take 13.6 minus 1.51. So that will come out to be, because we are having calculator with us, 1.51, yes, so 12.09. Yeah. And what is the energy gap for X? This is for Y. So it will be this minus this. So you can say 13.6 minus 3.4. Yes. So my answer is 10.2. Okay, so after finding these energy gaps, now we can find the wavelength. Like the photon will be emitted from Y, so that photon will be having this energy. So you can find the wavelength from that. So it will be 12.09 is equal to hc by lambda. So I'm just taking it as lambda in the case of Y, hc divided by 12.09. Similarly, lambda x will be hc divided by 10.2. Yes. So we want to find the ratio here for the wavelength of X divided by Y. So it will be this divided by this. So they are inversely proportional. So that will be 12.09 divided by 10.2. So clearly it is neither A nor D. So these two options are clearly out. And this value is definitely coming out to be greater than 1. So the answer will be C, that is 32 by 27, because this value is lesser than 1. So this is how we do this question, dear students. Thanks for watching the video. This is Professor Varun. Please share the video with all your friends. Also join the YouTube channel to access the solutions for paper 2. All the best. Bye.